of fraternities and sororities are required to volunteer for community service? Do fraternity brothers work a different amount of volunteer hours on average than sorority sisters? The data below shows the number of volunteer hours worked for 10 randomly selected fraternity brothers and 10 randomly selected sorority sisters. We're going to assume both populations are normally distributed, and the average one is the average of community service hours worked by the fraternity brothers. So the average that comes from this sample is going to be mu1, and the average that comes from this sample is going to be mu2. Now, both of them have a sample size of 10, and this question is asking if the fraternity brothers work a different amount of volunteer hours, which means this is going to be a two-tailed test. So we are going to say that mu1 is equal to mu2 for the null hypothesis. And because we're doing a two-tailed test for the alternative hypothesis, we're going to do mu1 is not equal to mu2. Now, I know this is going to be a two-sample t-test because we were not given the population standard deviation, and we're going to use an alpha level of 0.01. So, because we're given the data, take a minute and enter your data in your edit list under L1 and L2. The men's or the brothers should go into L1 and the sisters should go into L2. Once you have that data listed in there, we're going to run a two-sample t-test, but using the data. So I'm going to hit the stat button. I'm going to arrow over to tests, and I'm going to go down to two-sample t-test. And I'm going to tell the calculator to do this from data, from list 1 and list 2. Now, because this is a two-tailed test, we're going to use the does not equal sign to let the calculator know we're doing a two-tailed test. And then we're going to come down and we're going to hit the calculate button. And then it's going to give us all of our information here. Now, for the test statistic, we get that the test statistic, we know it's t because we did a t-test. And the test statistic, if we round it to 4 places, we get 0.4842, and that's negative. So when we look at our graph, our test statistic is over on the left side. So when we do our critical value, down here in step 3, we're going to use the negative value on the left side, because for this one where we're looking to see if it's a different amount, it could be either tail. That's why it's two-tailed. We don't care if it's in this tail or this tail. It could be either one. And this test statistic is telling me that it's in the left tail. So we want to make sure that we use negatives for our critical values in test statistics. Okay, now our p-value for this is 0.6342 when we round it to 4 places. So 0.6342. Now, let's find the critical value for the rejection region. So our rejection region is in the two tails, but the total rejection area is based on the alpha level, and the alpha level is 0.01. Since this is two-tailed, we have to split that rejection region. We have to split that 0.01 into 2 for each of these rejection regions. So the left side is going to be 0.005 when we split that in half. And then this is going to be 0.005. So the total rejection region area, when we add it up, is going to be 0.0. So when we find our critical value, we're going to use inverse t. And so when I look on the calculator, I get the degrees of freedom from the calculator is 17.73256.519. Okay, so let's do our critical value. We're going to hit second and bars, and we're going to use inverse t because we're using the t distribution. I'm going to put in that the area is 0.005, and my degrees of freedom is 17.73256.519. So I get that my critical value is going to be negative 2.8835 when we round it to 4 places. Okay, so that's this cutoff area right here for the rejection region. Now, if we were looking at the right-tailed region, it would be the same number but positive on the other side. So now to see if our test statistic falls in the rejection region, here's 0. And so our test statistic is negative 0.4842. So that falls between 0 and my critical value. It doesn't fall in the red area. There's my test statistic. It should fall right in here. So that means it's not in the rejection region, which means we're going to fail to reject the null hypothesis. Now, when we do this using the p-value, I want to look to see if my p-value is less than or greater than alpha. So if I look at my alpha level, it's 0.01. My p-value is 0.6342. So my p-value is greater than my alpha, which means we're going to fail to reject the null again. All right, so because we're failing to reject the null hypothesis, we would say there is not sufficient evidence to conclude that the population mean number of volunteer hours for fraternity brothers is different than the mean number of volunteer hours of the sorority sisters.